Aquaculture, like fish farming, is about water because anything they feed on is in water.
Yes.
They stay in water. Everything is about what? Water. That means it is very key to have the quality of water to standard. So most aquaculture is recommended that their parameters to be checked. For example, the pH, the salt levels, the organic matter concentrations, and most of the time when they dissolve oxygen. So that's very key to us. And every day we have to measure and check if all these parameters are in the right standards
Every single day.
every single day. And most of the time you have to do it twice a day,
Twice a day.
twice a day, and from different tanks, and not even from different tanks, in the same tank, different spaces. So you
Same tank, different spaces.
yes, and different tanks. Yes,
Do
because you
you
might
do the
find
same for the upper tanks?
yes, if different tanks, because you might find the problem here. These things are isolated. The problem here might not be the problem here,
Down
and
here.
you can look even these models. The problem here might not be the problem because
Then,
they're running independently. If
uh-huh,
this mature, this not mature. The
uh-huh,
water here, you can even see the color. The water here and the water here are not the same.
uh-huh.
Yeah, so we are going to use this sensor thing. It's going to advise us. So, for example, it's calibrated. It looks at what we call the dissolved solutes. It looks at the pH, the conductivity, and salinity, the salt levels. So it has to be dipped into the water. So when you dip it, it starts like looking at the quality of the water. So, for example, the first thing that is checking here is the salt level and is bringing in terms of percentage. And the second thing below here is the temperature. So
Okay.
we can now say here that the salt level of this water is 0.04,
Okay.
which is very good for fish to thrive. So that means this water is fresh and not salty.
Fresh for fish. Fresh for fish. I repeat, fresh for fish. Uh-huh.
No, I can also do the second thing you can check there is the temperature, which is around 23, 22.5 to 23, which is still recommended for tilapia to thrive in. So most of the time, that means you have to check it in the morning, in the evening, and even daytime to check what are the right times for what was the different temperature times. So we look for another parameter. We're going to check for the pH, and you can see the pH of this water is 8.5. Yes, so the pH is around 8.5, which is highly recommended and it's good for fish to thrive in. That's
Okay.
close to neutral. Yes, so we can check for other parameters like the conductivity, which is around 1,000, and it should not supersede 3,000. So this is very good for
Let
fish
me
to be.
ask, what do you mean by productivity? Is it the
No
number of
conductivity.
fish? Is it
No, I'm saying conductivity.
conductivity?
Yes.
What do you mean by that?
Yeah, so conductivity is about this water itself has ions,
Uh-huh.
and it has ions. So you have to check at how that can affect the fish growth. So that means if there are many ions, maybe the conductivity is so high, probably that will affect fish growth in one way or the other. And if it is low still, that means it can also affect fish in one way or the other. So the recommended is either between 500, actually sometimes 300 to 1500.
Yeah.
Yeah, so if you're that range, if the size, like, let's give you a simple example with organic solvent. So if there's a lot of organic matter in this water, what
Yes.
happens? It will be smelling. There will be breakdown of ammonia and other things and urea, and might affect the fish growth. Yes, that's what we mean also with the conductivity. So it's not to be high or very low. It will be in a moderate level.
Okay. Jack, I'm curious to find out. You mentioned that that instrument, what's the name, first of all?
Just say
Water sensor.
water sensor.
So the water sensor tests for pH,
It tests for pH,
salinity,
salinity,
and conductivity.
conductivity, and dissolved oxygen and
Okay.
dissolved organic matter.
Dissolved organic matter.
Yes, or particles. Yeah.
Ideally, what is it that would affect or change, make the pH of water change?
Yeah. So remember, the fish are fed daily,
So
and
the
you are
food.
giving them food externally.
Uh-huh.
So that can affect the
The,
water quality.
uh-huh.
So whether you are doing overfeeding or underfeeding, it can affect because these are also made from other organic
Organic
components,
matters,
yes,
yeah.
that can also affect the water quality. Because if you get a lot of uneaten feed here, then you get what we call acidic bacteria digesting this. What will happen? It will be more. The water will be more acidic.
Acidic,
Yes, and that can affect the pH, whether on the acid negative or positive. And the same also with the feed. If you get a lot of feed deposits, it can also produce those ions. The breakdown of the other things in this water that can also produce those ions that can also affect the quality of the water. But also, lastly, it tells you where the water is coming from, because you might also get rainwater, and because of it is coming from the atmosphere. If the atmosphere is toxic, with maybe heavy metals, other things, it can be acidic rain. And if you're using it for fish, you can also identify whether the water is acidic or not, or even salt. If you are using borehole water or salty water, it can also identify. So the essence of this is just to make sure that the water is ever quality, is over to standard, and that has to be checked daily. And in case you see any problem, you can act promptly so that you minimize chances of losing your fish in terms of death because of those changes in the water quality.
Okay, that's interesting to note. I know I am not overthinking. I'm just this curious learner. Maybe even our viewers are curious learners. Does biomass, let's say the excretions that the fish produce, also alter the pH? And is that the reason why? If yes, is it also one of the reasons why you're very intentional in a way removing those excretions, and you've mentioned you process them, recycle them to make other byproducts? Is that one of the reasons?
Yes, I can tell you today that that's why pond farming has become unsustainable, because when you feed fish, there's what we call heavy deposits of the biomass coming from the poops. And because if you have more fish, that means they are producing more poops. And reaches a time that there might be a chances of anaerobic digestion. So what we mean by anaerobic digestion is whereby in the bed of the pond, what happens? The compost or the heaps of the poops start like going under anaerobic digestion, using anaerobic bacteria, and that can produce even toxin things, or things that might interfere with the like breakdown of urea, and the ammonia can interfere with fish health, and even fish growth and replication.
Okay.
Yes, that's very key. And maybe I take you slightly to what has been happening to the lake. You hear there are times that the fish, like there's massive death of fish in the lake. What happens that when those deposits that are down there at the bed of the lake comes down, they suffocate the fish because they reduce penetration of oxygen going down, and also they bring toxic things up where the fish stays, and that's where they are able to kill fish. So in essence, fish need to know to stay, like you humans, you can't stay from where you remove your waste. It has to stay in a clean channel or a clean ecosystem. So any system that is focused in removing the entire or even half of the waste coming from the fish is recommended a good system for fish to grow.
Okay,
Yes.
those are good insights you're sharing. I'm curious, asking out of curiosity, how often do you clean the fish ponds so that you can just read the ponds of read the tank?
Better.
Sorry, this is not a pond. Correction, this is a tank. So how often do you clean the tanks to rid them of the waste?
Yeah, so our system is automated, like I said, it's gravity driven. So it is automated. So that means it is clean daily. So the water moves in between the tanks. And when it moves, the dirty water moves out of the tank. We are able to trap
Uh-huh.
those organic components every time water moves inside this system.
Uh-huh.
So every hour, every minute, every second that water moves here, we remove at least some portion of the particles that are here. One thing that we've been sure of, that we never found, instead of maybe heavy deposits of uneaten materials or fish poops that are remaining inside, we kind of remove everything because we get them through positive pressure
Okay.
in this water. Yes.
All right, that's really nice. Earlier on, you mentioned that you recycle that waste, and one of the things you make out of the waste is organic
Organic
plant feed,
fertilizer, yes.
organic fertilizer. You have asking for. I am curious, and also asking for a curious viewer there. You have right now 8 tanks Your space has the potential of having 16 tanks. You're halfway there and going. And at the moment, you have the potential to rear 16,000 to 20,000 fish. With that kind of capacity, what kind of quantity with regard to organic fertilizer can you make out of this?
Yeah, so for now, what we are sure of is that one vertical lake standing can give us up to around at 1 ton.
One ton
1 ton when
of
it is already
fertilizer
fermented
when
of
fermented
fertilizer.
there.
Yes, so that means the biomass that we are getting from here is around half a ton.
Uh-huh.
Yeah, yes, but yes, so that means each and every vertical lake that is standing should be able to give us a ton and a ton and a ton and a ton
Uh-huh.
of the organic fertilizer. But this is
Okay.
dependent on the size of the fish because the bigger they are, the more food they consume and the more biomass you get. The
Uh-huh.
smaller ones give very small biomass. It also depend on the size of the fish,
Mm.
even the feeding pattern, because we realize that sometimes when the temperature is so below is a little low, like below 15 degrees, they are not really vigorous, so they don't feed a lot. So that means we get less biomass coming
You
from this
get
system.
less.
But the essence, the concept here, can we get as much as biomass from this entire system?
Yes.
Yes.
Ah, that's nice. Thanks for sharing that. And when you say 1 ton, is it 1 ton in a year, 1 ton in a month, one
No,
ton quarterly?
uh, when we say 1 ton, we are targeting 1 ton in the entire cycle of the system.
Oh, that's
Yes,
6 months.
yeah, yes, the entire
Okay.
cycle.
Thank you very much for sharing that.
Yes.
I've been given something really, really nice here. I'm just about to feed the fish, and I will let him guide us into doing that.
So in this tank, we do have like a full-grown fish around 1,000, between 400 to 800 or even more in size grams of fish. So they are big ones, and they are right now we are focusing on selling the tanks, the fish coming from this tank. So for today, we are going to do the feeding.
Uh-huh.
So feeding is like we already approximated. This container is around 2 kilogram approximately of feed when it is full. So they need to feed. So feeding is just like you need to uh, take portion of the feed and the throw. So this feed is this one you can just eat. This one is a floating feed,
Yeah.
and you also we all know that tilapia is a feeder, so that means they like feeding from up, from the
Yeah.
top or the surface of the water.
Okay.
So when you put the feed on top, they will be able to know and they will come for it. Unlike the catfish that normally dwell
From
from
the
below the
ground,
tank.
from below
Yeah,
the tank.
yeah. So they will start coming.
I actually have seen them.
Yeah,
Do we do you just do that, or should we also go to their side? You feed them from one side. Oh, I can see them. That's
we
nice.
we feed them from every corner.
Every corner.
Yes.
This is really fun for someone who grew up in the city. Um, the best I've done before is feed fish in a tank, the really small tanks that are usually kept in the house or in offices and all. So I'm really enjoying this. Thank you so much, Jack, for this experience.
Yeah, you come even this side. Alafu unaweka mingi, sio hivyo, yaani mingi at one point. Hivyo.
Oh, this is really nice.
Yeah, it's artistic because even if you are here, most of the time, when for us, it's not even about feeding. It's like you get the breeze, you get the cool flow of the water. It's kind of natural thing, and just seeing the fish feeding is nice.
It is. Should I go there or the water will push back the
They
feed
will push
inside?
back. Yeah, they will push back.
Is that enough for
No,
today, or
wataongeza.
do I put all of it?
Yeah, we that's not enough. We'll add them as they finish this.
Okay.
Yeah.
So we are on the second tank up. There are two more tanks above me. We've just fed the fish that are on the first tank closest to the ground. I'm here to feed the fish in the second tank. Bye.